Good evening, everyone. We'll wait for 5 more minutes, let them join, and we'll continue then.
Sir, can we start?
Okay, let them join. We'll continue. Good evening, everyone.
Yeah, please start because if no one is here, no problem. They will see the recording.
Yes, yes. Yeah. Today we'll see one more heat load calculation, especially for winter season, and we'll do an exercise for this also. How we can calculate, and one more topic is pending, that is dehumidification, and theory is going to cover, and probably from Sunday onwards we'll start some new topics like drawing things. Sick.
Sir, what about HAPE? When we will try HAPE?
Yeah, so our next things will be like towards tools actually. So theory things will be over, and like next meeting will be towards like we'll talk about tools like drawing tools as well as different apps, calculators things. We'll move towards tools.
Okay, I think chilled water piping sizing is also pending.
Which piping size?
Chilled water.
Shield water.
Yes,
Okay. Okay, let me check then. Shield water piping size, huh?
yes.
Okay. Okay, I'll check, and let's see. We'll complete these things. Dehumidification as well as this particular winter load calculation, how we can do and how we can size a particular AHU for that, or ton of refrigerator. So we'll see now. Like before that, previous meet, let me just a second. Inside beside. One more thing need to open. Just a second. Yeah. So today we'll see this winter load calculation during our winter season. How we can, since outside will be a bit colder, so how we can warm up inside that. Based on like human comfort at all, how we can particularly rise the temperature inside the room, how much temperature we want. So that particular calculation we will do, mathematical correlation we will find. So how we can design that, we'll see today. So during design condition of this winter load calculation, we have to see certain things like it will be like almost previous like last meeting calculation, heat load calculation, almost similar things, but few changes will be there. So during our design condition, as well as like we need to see first of all area of the room, how much area. So then we need to see about what will be the temperature, like outdoor temperature and indoor temperature. So those things we need to see. And then what about how much heat is lost through the wall, that we need to calculate. And then also we need to calculate window heat loss, because in window there will be certain classes, so there will be temperature change between indoor to outdoor due to temperature difference, so that we need to calculate. We need to also calculate roof heat loss, because it is exposed to ambient, so there will be temperature difference. So again there will be heat loss. And then floor heat loss also we need to calculate, as well as infiltration. And what about how many occupancy is there, that we need to calculate. So these are the few things we need to calculate ultimately, and then we can size our uh, that age. So now we'll see one by one. So hope my screen is visible. Hello, I'm audible.
Yes,
Yeah.
yes, sir. Yes, sir.
Yep. Okay, so we'll continue on these things then. So we can see this is one room, and we have multiples window things, and then like these are different dimension as well as door dimension also. Yeah. So based on like consider a room. So using this room, how we can calculate heat load during winter season. Okay. So first of all, we need to calculate area. So let's calculate area. Area calculation. Okay. So how we can calculate area? We need to see this.
Window area is the 40.
Mhm. So okay. So we'll calculate the hall size. Okay. So what about that hall size completely? That we'll see now. Calculate hall size. So this is complete hall, which is, so you can see this is the length and this is the width. So that area is nothing but length into width. So 50. Uh, First of all, we enter this.
50 into 30 is the 1,500.
Yes, yes. 1 second. So first, let me write this down. Then it will be easy for us. Length is 50 feet. Then it is 30 feet. Okay. And
30 in the width,
so
na, is the height.
mhm.
You know,
Yes, please.
30 is the width, not the height. Mm,
No, width actually.
G? Say
Width,
yes?
width.
Okay, okay. If the symbol
Yeah.
is the H na, so I think you confuse.
Okay, okay. Width. So let
The W, no?
yeah.
Yes, yes,
So
okay.
now it will be, so hall size will be like equals to 50 multiplied by 30. So it's like 1500 feet square. Okay. So we calculate the hall size. Okay. Now we have different things like one is office, one is, so that area also we need to calculate. So what about the write down first office, office, office
Hello.
dimension
So
is
your
like,
voice is the break, sir. काफी मतलब not be clear. Break.
oh my,
Break.
okay, my voice is, so what about now?
Break. Yes, break,
Is it
break.
audible?
Yes, 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 yes.
Oh, okay.
It's a net issue, I think so. I think it's a net issue. Not the
Think
problem.
some internet issue. Okay, fine. So let's
Yes, sir, yes,
continue
sir.
then. Okay. So that office area will be, so office length is 10, so which is this one, or width is 10, like 10 feet, and height is here, it's given 10 feet. Okay, so let's consider um, length is 10. We'll consider LO, which is LO is office, length of office, and then length of store. We'll see. So width of office is 10 feet. It's 10 feet. So length of office, length of store is nothing but it's 10 only, 10 feet, and width of store is, so you can see here. So it's nothing but width is 20 feet. So now we'll calculate hall. We already calculate hall size. Now we calculate office size. Office size, which is 10 times of like this is 100 feet square. And then we'll calculate store size. Store size is equals to times of this. So okay. So now we calculate the area of individually. Okay, hall area we calculated. We calculated office area. We calculated store area. Now, what about the total area? So now we need to calculate the total area. So let's consider total area. Okay. Total area equals to, we need to add all the three completely. Like this is hall area, office area, and store area. We need to add. So let first office and then this. So we got this much of feet square area. Okay, so we got our total area. Let's highlight here. We got total area. Now,
Hello,
yep,
sir.
yes,
I think hall area will be 1200 square feet because total area is 1500 square feet. How
uh-huh.
can hall size will be 1500? It will be 50 minus 10, that is 40 into 30, 1200.
40 into 30. Okay, yes, exactly. It should be 40 into 30, correct. It should not 50 into 30.
Not that one, not that one. Niche, hall size. Hall size.
Yes,
Yes.
yes, there is only. So 1200. Okay, so now total area will be 1500 feet square. Okay, now let's consider certain assumption regarding temperature. Okay, so we'll see assumption of temperature. Temperature. So what about temperature? Let's consider outside temperature is 10 degrees Celsius and inside temperature will be like human comfort temperature 22 degrees Celsius. So T out, let's consider 10 degrees Celsius and degree C, and T inside temperature is 22 degrees Celsius. So let's consider these two conditions. So which is 72 50 degree Fahrenheit and second C2F. So 10, 10 is 50 and 22 will be 72, 72 degree Fahrenheit. So this is the temperature condition. Assume that, and here it's given like FCH is nothing but floor to ceiling. That height is 12 feet. Let's consider, and slab height. So let's consider the slab height also. Slab height is 15 feet. Okay, so it's already given. So like floor to ceiling, that also we need to see. It's floor to ceiling. Ceiling is okay. So it is 15 feet and slab.
The
Yep.
floor to ceiling height is a 12 feet. The mention is the
Oh
map
yeah.
layout.
So 12. Correct. Floor to ceiling is 12
Okay.
and slab height. Exactly. Slab height.
Okay.
Slab
Slab,
height.
the floor to slab height is the 15, yeah?
Yes. Yes. So slab height is 50. Now we have the temperature readings. We have height. We have area. So we'll move toward our design calculation. Like first of all, we need to calculate the heat loss. Okay. So now we'll calculate heat loss. Heat loss. That what we need to see first of all, heat loss due to this particular wall we need to calculate. How much? Let's consider windows is not there. Only this particular wall is present. Okay. So what is the total area of wall? Through that only heat will exchange. Okay. So we need to calculate this. So wall will be like 1 second. Yeah. So now we have the total, like we need to calculate the total area where this particular heat will exchange through wall. So we already calculated the total area. So if you subtract this complete, this particular window area, so we'll get the exact total area of wall, which is contributing the heat transfer between indoor to outdoor. So now we'll see that one. So in heat loss, we'll consider A, which is called as wall heat loss. Wall heat loss. In wall heat loss, we have total area of 1500 and how many windows? So windows is 5. Yes, please. Hello. Am I audible? Hello.
Yes.
Yeah. Okay. So I was just saying we need to calculate this particular window area so that we can subtract this from wall total area, and then we'll get the complete wall area. Okay. So to see this window height, so let's consider height window is 5 feet, 5 feet, and with this of window is 4 feet. So which is these dimensions. So how many windows we have? 1, 2, 3, 4, 5. Okay. So now let's calculate the area. So area is equals to height into feet. So into feet square. Okay. So this is the area. So how many windows we have? 1, 2, 3, 4, 5. So it's like 5 times of 5 times of this. So it is 100 feet square. Now we need to calculate the wall area. So wall area is equals to total area minus window area. Okay, so we got the wall area is 1400 feet square. So this is the area which is going to
All
contain.
window area the 5 feet, na, the 4 feet. Hello.
Yeah, please.
Yes, all window is the 5 feet.
Yeah, all window we need to calculate, because see, we already calculate the complete things, right? So area of the complete room, or complete building, we can say. So in that, 5 windows
What
is there. So
it is 4 feet. 4 feet is the what the 4 feet? The window is the 5 feet. Hello.
yes, so yeah, window is like height is 5 feet, and width is 4 feet.
I with 4. Okay. Okay.
Can you repeat one more time? Hello.
Yeah, yes, please.
What?
Okay, so we'll continue then. So that we complete wall area we got is 1400. Okay, so we have this correlation to calculate the heat loss. So wall heat loss we need to calculate. So that is Q is equals to UA delta T. Okay, so UA delta T, that is wall heat loss. Okay, so we need to calculate using this correlation. So heat loss through wall, heat loss through wall, how much will be like So let's consider. We already discussed multiple times how we can calculate this overall heat transfer coefficient, which is U. A is nothing but your area that contributing heat transfer, and temperature delta T is temperature difference between outdoor to indoor. Okay, so let's consider U overall heat transfer coefficient for wall is 0.3, which we already calculated. Okay, through using our previous method, like how we can calculate the U. Okay, so now comes to 0.3 times of area is wall area times of delta T. So delta T will be temperature difference. So which is nothing but 72 minus 50. So our heat loss will be 9240 BTU per, okay, per hour. Okay, so that will be heat loss through wall. Now similarly we need to calculate for window also. Next we need to calculate P, that is glass heat loss, window heat loss. Okay, window heat loss, that will be same, which is Q is equals to UA delta T. Okay, so now we have this area of window and glass. Like for glass, overall heat transfer coefficient, let's consider 1.1. Now we'll heat loss through glass, heat loss through glass. Okay, so that will be, consider 1.1 will be the overall heat transfer coefficient times of U A delta T. So A is this area, okay, times of delta T. So delta T is nothing but this 72 minus 50. Okay, so 2420 BTU per hour. So we got this. We got heat loss through glass or window. Okay. Now we'll go for 3, which is heat loss through roof. We'll consider heat loss roof heat loss. Okay, we consider roof heat loss. Okay, so in roof heat loss also the correlation is same, which is Q and delta T. Now so that particular complete area, this complete area is will be roof area. Okay, so this complete area we already calculate, which is 1500 feet square. So same thing we need to calculate here. So that is heat loss through roof. Loss Can anybody please calculate these things and let me know? Yeah, my U value is 0.25. That's considered U is 0.25. Hello.
Now, what is del T? Your screen is
Yeah.
not showing the
So
del T. Your Excel is not
yeah.
showing the
Okay.
del T.
Sure. Yes. Delta is here.
Uh, 2022. Sir, 8250.
8250. Okay. Then we'll calculate
Yeah,
here.
0.25 now. You have said you
Yes.
0.25.
0.25. Correct.
Yes,
Yes.
0.25 into 1500 into 22.
0.25 into 1500 into delta t. So delta t is here 72 minus 50. Exactly. 8250 is the correct answer. So similarly, we need to calculate for floor heat loss. Okay. So now we'll go for 4. So can anybody please tell me which formula we need to use for floor heat loss?
I think this will be same.
Yeah, exactly. So same correlation we are going to use because this is the convection correlation. Since we already explained, like since we already talk about like suppose this is my indoor room and this is my outdoor room. So what will happen, that cold air is already like blowing over this wall. So due to that, what will happen, whatever the warm insideness is there, that will transfer through heat will transfer through conduction through wall, like, and then heat will transfer via convection. So now ultimately convection is happening here. So at this point, convection, through convection only heat is transferred. So we know that Newton law of cooling, the correlation is Q is equals to UA delta T. So that U, how we calculate, we already know about this. A is just now we see like on how this A can be calculated, and delta T is just temperature change between indoor to outdoor. So this same correlation we are going to use, that will be like, so let's consider this is uh, heat loss through this roof. So heat loss through heat loss through floor. Okay. So again same correlation. So it will be like let's consider 0.4. Yeah, like always if you carefully see, the U value is continuously changing. Why? Because based on the materials, so floor materials will be different, and then like roof material will be different, window material will be different. So based on that, through Asher table, you need to calculate the total resistance. So 1 by total resistance is nothing but overall heat transfer coefficient, which is U. Okay, so that is zero point 0.4 times of area. So area will be the same times of delta T. So delta T is 22. So this 13,200 BTU per hour. This will be the heat loss through floor. Now we need to calculate the infiltration thing. Okay, so for 5 we need to calculate infiltration. Infiltration. So infiltration will be like that. So we need to assume our air changing, how much air is air charge unit actually. So ACH we call as ACH. Let's consider 1.5. So first of all we need to calculate this room volume. So how we can calculate this room volume, because our infiltration will be calculated based on CFM, which is cubic feet per minute. So we need to calculate the entire volume of the complete considered room. So we already see, we already saw this, like our this floor to ceiling height is 12 feet. So if we consider height into area, that will get volume. Okay, so now we'll calculate the volume. So room volume, we'll consider volume. Volume will be, so our area times of this complete floor to ceiling height. So this much is the volume in terms of feet cube. Okay, hope till now it is clear. Any doubt, please let me know.
Sir, you complete this, then I will ask questions.
Okay, sure then. So now we need to calculate the airflow. So which is nothing but CFM. So airflow. So CFM is, we already know the correlation is volume into SEH divided by 60. This is the correlation. Same thing we are going to use. So our volume is 1800 times of SEH will be 1.5, and then divided by 60. So we got 450 CFM. Okay. So we got our infiltration also. Now we need to calculate, since people will be present here. So multiple assembly, like consider number of people will be 50. So how much heat will gain inside the room, so that we need to calculate. So next 6 will be it's like people heat gain. People heat gain, heat gain. So that will be same like as per SI standard. So as per the SI standard, we know this per person latent heat will be like 250 BTU per hour per person. Let's consider here itself 250 BTU per hour, BTU per hour per person. Okay, so we have total number of person is total number person is like 50. So now we can calculate uh, heat gain, heat gain, heat gain by people. Okay, so heat gain by people, total heat per person times of how many number of person. So now we got this much of heat gain, this BTU per hour. So now, so this is the heat will gain inside the room. So now we need to calculate the total load. Okay, first of all we need to calculate total load. Let's consider into different color, and we'll calculate total load. Total heat loss, which will be equals to, so which will be like heat loss through wall plus heat loss through glass plus heat loss through roof plus heat loss through floor. Okay, plus so that yeah. Okay, before that just a second, we need to add one more thing here, because air infiltration we just calculated the uh, what you can say CFM, but we need to calculate the heat load also. So that, let's consider that also, how much heat will be gained for that. So we know that how we can calculate the heat loss. So heat loss through infiltration, heat loss through infiltration, let's consider. correlation will be like so we have correlation which is Q is equals to mcp delta t. So Q is equals to, or we have directly as a standard formula, this one 1.08 times of CFM. We already see this correlation in our previously. Okay, 1.08 times of CFM times of delta t. Same correlation we're going to use. So which is equals to 1.08 times of CFM is 450 times of delta t will be like 22. So this much PQ per hour. So it's PQ per hour. Now we'll move toward total heat loss. So that we need to add one more thing. What we need, what we already added, that is, you can see here, heat loss through wall. This one, heat loss through glass, heat loss through roof, and then we added heat loss through floor. Now we need to add this load also due to infiltration plus heat loss through infiltration. So this is the total amount of heat that is going to lose. So this is the load going to lose. Now,
Sir,
yep,
I think heat gain through by people also need to be added.
sorry,
The 6 point will have to be added with this, I think.
yeah,
If you
we
don't
already
add.
added. Yeah, you already added. You can see here. So heat flow through infiltration also we added.
No, point six, number six. Heat gain by
Uh,
people.
yes. So in this regard, we'll explain actually what here, whatever the amount of heat we already added, that is loss actually. So because you can see this, for this winter condition, what exactly happen is outside air is cold, inside air is bit warm, right? So that outside, since outside air is cold, so that air is trying to get heated up through by taking the some amount of heat from
Yes,
the indoor.
yeah, that will be negative.
Yeah. So how much, yeah, so how much amount of heat is going to lose? Okay, so that we have calculated. But if you see the number of people, so the people will be always some latent heat will be emit. Okay, so that if you have 50% in a room, you will feel bit warm compared to like normal condition because of latent heat. So that latent heat we need to subtract from that the heat loss. So that will do now. So this is total heat loss. Okay, now so we need to calculate net heat load which air handling unit need to be designed. So next is net heat load. Net heat load. So in net heat load, what we need to calculate is total heat loss minus how much heat gain by vapor. So that will be our net heat load. Okay. So this much BTU per hour will be net heat load. It's like BTU per hour. So now our ultimate things need to be designed is like how much So how much for this much load we need to design our what is that heating element actually. So how we can size those particular heater? So we know that that is like 1 BTU per hour is equals to, let me consider here, 1 BTU per hour equals to, has to do on unit conversion that we already saw in previous meet, that is 3412 kilowatt. So, so that heating load heating load will be, so this much amount of heat is required. So now we'll calculate the heating load. So equals to this much load divided by 3412. So we need our heater has to be 12.83 kilowatt. So since like 12.83 is not available, round up we can go, which is 13 kilowatt. Ultimately, we need to in summer condition, what we designed how much ton of refrigerant we want. Okay, but in winter condition, we need to calculate the heater capacity actually, how much load of heater is required. Okay, so for this condition 13 kilowatt load is required actually for to maintain 22 degrees Celsius inside the building. Any question please?
Yes, sir.
Yes please.
I have three or four doubts.
Yeah please.
Number one,
Uh-huh.
uh, you have calculated infiltration
Mm-hmm.
uh, from the formula ACH and the volume, right?
Yes.
I think there is another formula you have already taught us. That is, fascia CFM is equal to CFM per person into number of people per CFM per square feet into area, right?
Okay. Yeah, that also we can calculate through using our, if you have volume into SCH divided by 60, that using that also we can calculate.
But I have calculated in some other places that
Okay.
if you calculate in both the options, right, uh, the result will be different. What we
Uh,
take, what we
okay.
take, we take
Mm-hmm.
the higher side, মানে
Mm-hmm.
either this one or that one.
Okay.
So in this case, should we use this formula only?
Yeah, because our heat load calculation for the previous meeting also we use same formula,
No,
volume into SCH by
yes,
60.
but we have also মানে write as that is fascia CFM is equal to CFM per person
Mm-hmm.
into number of people plus CFM per square feet into area, the heat load.
People heat gain actually, this one you're
Yeah.
talking about,
No, no,
people
no,
heat
no,
gain,
no, 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 no. This is air flow, infiltration.
airflow.
Yeah.
Okay, just a second, then I'll clear these things. One second. Let me open this PPT then. Hope my screen is visible.
Yeah.
Yeah. So I am talking about this correlation where we can calculate this complete, like for air infiltration, or if any kind of certain air is going to enter inside the room, how we can calculate the total amount of heat. So using this correlation only we can calculate. So that is nothing but
So that is
Q.
okay, but
Mhm.
you not in this class, but check the thing from the heat load PPT also.
Okay, so what will be the correlation? Can you please tell me one more time so that I can?
Yeah, that will be there. This thing is in X-ray also.
Okay.
CFM per person
Yeah, CFM
into
per
number of
person,
people, into number of people,
number of pill.
people,
Okay,
number
okay.
occupancy,
Yes, yes, yes. CFM per
plus
person. Okay.
SAS square feet, মানে crack square feet into area.
Plus square feet into area.
Yeah. That is CFM per person into number of people actually.
Okay.
You have one table in X-ray also. Say
Mm-hmm.
for classroom, 7.5 CFM per person.
Okay.
So if there are 50 boys over there, so 50 to
Ah.
7.5 will be total CFM.
Yeah, yeah, yeah. That is for fresh air actually. So
Yeah,
if yeah, for people breathing, human comfort is there. So per person, this is the standard actually. So how much
yeah.
yeah, amount of air need to come, fresh air need to come. So for calculate that things, we that time we have used this correlation, but this is different.
Okay.
Sir, excuse me.
Uh,
Yes, please.
Sir, so in this ACH, air changes per hour,
Yes.
actually, what does it mean, sir?
So air changes per hour, like for fresh air actually it's a bit different, or for infiltration is bit different. Let me explain
Okay.
both the things. Fresh air in the sense, like if suppose 10% is continuously seated inside the room, so people will breathe, carbon dioxide will increase in the room. Okay, if there is no proper ventilation, so what engineer will do, as per ST standard, like 20 to 30% of uh, total room air, they will send 20 to 30% fresh air from outside actually. Remaining 70% they will keep in the room air itself. Outside air, from outside, 30% of air, 20 to 30% of air will bring from the outside. So that is nothing but air changing hour. So at hourly, how much air you are like changing from indoor to outdoor. Okay, this is one case. Other case is like infiltration was like I was talking about, like if any kind of crack is there in wall or roof, then what will happen, there will be air leakage. Or what will if certain window is suddenly open, and certain like high velocity of air is entered inside the room due to some certain several condition, like kind of cyclone or things, that time certain amount of heat will gain inside the room. Okay, so at what velocity it enter into the room, so based on that condition only, this value will be different.
Okay, okay, sir.
Okay, then we'll move to our regular thing.
hello.
Yes, please.
My second point is when we are calculating this heat gain through by
Mm-hmm.
people,
Mm-hmm.
uh, is it sensible?
Actually,
Sensible
latent
load,
heat. Latent heat.
latent heat. But there
Yes.
are two types of heat, na? Sensible heat and latent heat.
Yes.
For
Sense.
people, for people,
Uh-huh.
if you consider the action chart, there are
Mm-hmm.
two heats by people. One is
Mm-hmm.
sensible, one is latent.
Okay. Yeah.
So,
So, yeah, as per SS standard, per person amount of like total amount of heat will what is that, emit by a person, like healthy person, 250 BTU per hour. So total amount of heat, that is per person.
so you are telling that it is sensible plus latent.
Yes, total amount of heat per person is emitting 250 BTU per hour as per SS standard.
But when you are calculating the heat gain to people, the conversion that is 1.08 into del T,
Mm-hmm.
uh, that equation is for sensible only. For latent,
No.
it is 0.68.
Yeah, so you can see here how what we have done is we have ASHRAE standard, that is per person emitting in a healthy person actually. So it is 250 BTU per hour. So how many number of person, that will be just multiply this. So we get the total amount of heat emitted by people. But for this condition, it's different. Like our air is continuously blowing. Like we are calculating for infiltration. So we got how much airflow is happened. Okay, so 450 cfm we got the airflow. Now we need to
Per
calculate.
per person 250 BTU per hours.
Yes,
People heating again. Per person heating again.
yes, per person
Heating gain per person 250 BTU per hour.
250 BTU per hour.
I think I support that one hall office area is the 6 person. पर पर्सन हीटिंग जो हीटिंग गेन होगा वो 250 होगा 6 person का एक सेम नहीं होगा ना.
So per person as per SI standard is like 250 BTU per hour heat is emitting.
ओके ओके.
Okay, and this is like how much air is flowed, right, due to this infiltration. So how we can calculate the total heat gained through infiltration? So that is like CP 1.08. Okay, and CFM times of this one delta T, temperature difference.
Okay.
So that is
Sir,
that is
one
how
more
we,
question.
yeah.
Uh, I, I think there should be lighting load also.
Yeah, yes, exactly. So we need to add this point also, correct? So if, okay, let's consider. Yeah, it's good point. We need to add that point also. Let's consider. Seven is, so we will repeat this same thing here. same things let's consider, like how we calculated for cold storage. So just for an example, like for an example, like if two light is available and heating a load of 200 watt, and then so as per as standard, like per square foot area will be like 2 watt based on that. And so how much heat will get calculated, that is, just a second. So room area times of that. So just room area. So our room area will be a bit different. So that is, room area will be 1500. 1500. Now, like, watt will be 3000 watt. Okay. Now we need to convert 3000 watt to in terms of BTU per hour. Okay. So this much load is BTU per hour load will begin. So that amount of load we need, again we need to subtract from net heat load actually. So what we have done, this is for one is heat loss, like heat, total heat loss. We have subtract the heat gain through people. Now we need to subtract this amount of load also, lightning load. So lightning load will be this much. So now we have, this will be like, okay, so it should be not total heat loss, net heat gain, net heat gain by this. So it has to be 6.1, means we can go for 6.5 low. Okay, so this much capacity of heating that particular coil is required for this condition.
Sir, we have calculated the heat load for the
Mhm.
total area now, right?
Yes.
Now, when multi-purpose assembly hall will not run for the time when office and store run,
Okay.
because it will be people will gather occasionally, right?
Yes.
Now we have to calculate the separate three zones. Am I right?
Hmm. So like for this for this problem we have considered at a instant position, like okay, for separate load we can calculate, but what we can do is we have to design the maximum condition, right? For this room, if we have like for 50% of occupancy, at the maximum condition only we have to design, right? So for 50% if we have, then this much load is required.
No, sir, because uh, if we calculate the total heat load, the
Hmm.
system will be a single dedicated system, not the individual one.
Okay.
Say 6 kilowatt. Now,
Okay.
when multiple assembly hall is not working, office and
Hmm.
store is working, then
Hmm.
that 6 kilowatt will run for both the three places. So energy will be lost.
Okay. Yeah. Okay. So
So
in that, yeah, please.
that is a design consideration.
Yes.
And when we calculate separately,
Hmm.
then the wall which is in the boundary of this multiple assembly and the office, it will
Hmm.
not be the outside wall, it will be a partition wall. So
Yes.
heat load will be different.
Yes. So in that case, what you can do is, for an example, what we have done right now, that is complete building we have considered. Okay, same calculation we can done for this complete office room. Similarly, for storeroom,
Yes.
you can done for same calculation you can done for multi-purpose assembly. So based on your occupancy, that result will vary. As well as since your area is going to vary right now, then you can like what we can do is, for an example, we you can see here what we've done is we have that length width, which is this one. So just now we got area. Now we can individually calculate for using this area only, because we have calculated for total area which is complete this one. So if you do for individually, so we need to just calculate same like u by delta t, which is u is that value, and area we need to calculate this 1200 feet square. Okay, so similarly for office size it will be 100 feet square, for store size it will be 200 feet square. So that is how we need to calculate for individually. We can do that. If you want to, you can do an exercise for this also
I
by
think,
using.
sir, I think you will explain in detail while calculating it with HAP, because we need to, in the software, we need to find out the conduction load of wall for the four direction, north, south, west, and east,
Yeah.
right? So
Yes.
I think that will be calculated when we are going in detail.
Yeah, we can do that. So
Yes.
okay. So okay. Let me. I'll go quickly for this complete calculation one more time, and we'll see. So what we have done is we have listed out what will be our length and width for different rooms. Like so we have multi-assembly room, we have office room, we have a store room that we have noted down here, and we assume a temperature condition like outdoor temperature is 10 degrees Celsius, and I want indoor temperature should be 22 degrees Celsius. So for that, how we can design a heater for this actually to heat this complete room. So like for that, what we have done is we calculate the heat loss through especially wall, through roof, through floor, and through glass. Okay, so we have calculated that like heat loss through wall, so this much BTU per hour, heat loss through glass, this much BTU per hour, heat loss through roof, this much BTU per hour, heat loss through floor, this much BTU per hour, and then infiltration. So based on infiltration, how much CFM is going to enter? This is 450 CFM going to enter. So due to that, how much heat load? Total heat load will be this much BTU per hour. Now, so there are inside the room there will be lighting element and people. So these two things, electrical equipment and people, so these are two things is producing heat actually. So this heat generation we need to calculate. So based on the light, we got like how much heat is going to generate, and through people how much heat is going to generate we got. And then what we have done is heat total heat loss through wall, through window, through roof, through slab, through infiltration, that we have added. And then what we have done is net heat load. In the net heat load, what we have done, how much heat loss was happened and how much heat was gained inside the room due to light and these people. So that much amount of net heat we have calculated. Now how we can calculate the heating element? So how much capacity of heater is required to to heat the room up to 22 degrees, like comfortable condition, like up to 22 degrees Celsius. So what we have done is, we know 1 BTU per hour is 3412 kilowatt. So just divided the net heat load, and this is the heat load is required, divided by this just unit conversion we have done, and we got 6.5 kilowatt of heating coil is required for that. So now for this room we can this is the maximum load is required for heating coil. So similarly, we can do for, if you want to do separate calculation and separate heating element. So suppose just now you told like multiple time this room will be not be used, or only office room or store room will be used. So at that time, what you can do, if you calculate, so particular heater will be on for this office, particular heater will be on for this store, and this will be off. So that will, what will happen, we can save our this particular energy consumption. So ultimate bill will be affected. So but if you go for like full things, then this much of heating coil is required. Okay, so any question please?
No, sir.
Okay. Okay, then shall we take a small break and then we'll continue a new topic then?
Yes, sir. Sir, request is there.
Yeah. Yes, yes,
Please,
please.
sir, please ask your technical software team
Okay.
to so that we can access the PPTs for the class PPTs, because there are several PPTs like cold storage and fan and pump.
Uh-huh.
We couldn't access, sir,
Oh, is it? Okay, okay. Then they have not shared, they have not provided you with access, and I'll definitely
because
talk with my
those
team.
classes those classes are over now. So we
Yes,
have
yes.
to access over here. Please,
Yeah, sure,
please,
sure.
sir.
So
Yeah, yeah,
yeah,
yeah.
sure. I'll talk with team and definitely they will give access.
Okay, thank you, sir.
Yeah. So we'll meet. It's 8:43. We'll meet up at 9 o'clock then.
Yes, sir.
Okay.
What is the time? What time? 9 o'clock.
Sorry. 9 o'clock. Yes.
Mm, hello.
Please.
Hello.
You,
Nine,
you,
15
your
minute
voice
break.
is no.
10 minutes.
Yeah. So 9 o'clock we'll meet. Okay. Okay.
Mm. Okay, okay, okay.
Well, we'll continue then. A new topic called dehumidification. Should we get started?
Yes, sir.
So, while one small topic is pending, that is dehumidifier. So we talk about humidifier as well as dehumidifier. So in previous meet we discussed about regarding humidification, like humidification in the sense of adding water in dry air is nothing but humidification. So opposite of that is nothing but dehumidification. So dehumidification in the sense, what about the moist air is there, uh, removing the water content from the moisture, so is nothing but dehumidification. So when this particular dehumidification is used, especially during after the coil, so if relative humidity percentage, like as per as standard human comfort, relative humidity is 50% relative humidity, and 22 degrees Celsius temperature is comfortable as per standard. For an example, once like it's a rainy season, and at the rainy season we know about this water content in air is bit more compared to the summer condition. So at this time, if the that air is passed through a cooling coil, so immediately condensation start. Okay, so condensation start, and we know if you decrease the air temperature, definitely relative humidity will be increased. So to avoid this excess amount of relative humidity, which is more than 50% as per human comfort standard, so that amount of relative humidity need to be extra. So in that case, what need to be done, like an particular heating coil or soak absorber like will be there. So those particularly, if you pass through heating coil of this higher relative humidity of air, what will happen due to the temperature, the bit air temperature will rise and relative humidity will decrease. So that relative humidity will decrease, and then due to that particularly, so that is how we can control the relative humidity through dehumidification. So now this will see about this topic. So especially dehumidifier is a device which reduced to maintain the humidity level at indoor, and removing especially excess amount of moisture. Okay, so this is an air handling unit. So you can see, like this fan is there. This fan is continuously sucking. So through this filter, air is going to pass due to suction, so that it will go to the extension drain. So there will have different things like extension drain pane, then heat pipe, then cooling coil, and then preheater heat pipe. Okay, so once the air is going to pass, it will go to the pre-cool heat pipe. So in that pre-cool heat pipe, so air will get bit cool, and humidity level will get increased. Once it is passing through cooling coil, then immediately humidity level will be higher, and then the air temperature will be also drop. So at this condition, you can see this pane is also there. So the drain pane, exactly what it is done, the condensate amount of water accumulated in the pane, so it will remove through this drain. And since to maintain this particular percentage of relative humidity, there will be a heater. It's like the reheater. So the term itself reheater, it's going to reheat again the air, though it is losing its energy, but to maintain this particular relative humidity, this process is must required actually. So now we'll see bit benefits of dehumidifier, and then disadvantage also, like dehumidifier will be like improved indoor air quality, then so condensation it will prevent, and then health benefits like comfort and health benefits will improve. So regarding disadvantage, disadvantage will be like we are losing energy at that point, and it's like extra thing which is consuming more power and adding cost to consumer actually. So now we'll see how we can select this dehumidifier, on what basis, and how we can calculate this particular size of humidifier. Okay, so to select this size of humidifier, we need to see two things. That is, what will be, first of all, what will be the room volume, and second will be like what will be the air changing rate. So room volume, in the sense like previously we saw how we can calculate the room volume, height into width into length into, then entire volume will get. So like area will get length into width, and then once you get area into height, then we'll get volume. So, and then what you can do is, we, based on our air changing rate, we need to take the value as per Astra, like for hospital 16 to 12 operating rooms. So we have different like ACH value for different conditions. So that particular table we need to use, and those numbers we need to consider from that, and then we can calculate this. So how much heat like heat it will gain or it will lose, we can calculate using this correlation, which is QCFM is equals to room volume into SEH by 60. So that room volume we just saw how we can calculate. SEH based on our SS table, and 60 is like this in terms of seconds actually. So minute, just BTU per hour, kinds of unit conversion. So determine the humidity ratio. So how we can calculate the humidity ratio? So it's like through psychrometric chart. If we have relative humidity of different temperatures, for an example, we have one indoor condition, which is now for 22 degrees Celsius and 50% relative humidity, and outdoor condition will be like 30 degrees Celsius and 40% relative humidity. So if you go to psychrometric, just put those two different conditions, and you will get humidity ratio. So that we can find from psychometric chart or this data necessary calculator. That numbers we can get from there. So how we can calculate the depression of actually dehumidification load? So that dehumidification load, how much CFM is air is going to leave, and then just humidity ratio times of 4.5. So 4.5 is like a conversion factor to air density actually. So that is how we can calculate humidity ratio. Okay. So can you please try this now, so that we'll get better clarity about this. So let's consider. Can you please note down this problem, and then we'll see how we can calculate this. So for an example, okay, please write this exercise. We'll try now, and we'll try to get a exact answer. You can use for psychrometric, you can use data history, or you can use the psychrometric chart. Whichever is you are comfortable, you can do that. So let's consider a room size, like length is 50 feet. Am I audible?
Yes.
Yeah. So okay. So length is 50 feet. Width is suppose 30 feet, and height is 12 feet. We have a room size. Okay. Now, how we can calculate the size of dehumidifier? You need to calculate size of dehumidifier. Okay. For that, you can use this correlation. Not an issue. Like so, to calculate dehumidification load is equals to Q times of humidity ratio 1 to humidity ratio 2 times of 4.5, and you can calculate Q through volume into SCH divided by 60. Okay. So now, and assume two different temperature condition, T1, T inlet, let's consider T inlet, and R inlet is T inlet is, let's consider 22 22 degrees Celsius, and R inlet is 50%. 22 degrees C and 50, and T out is 30 degrees C and 3% relative humidity. Can you calculate this? So can you just size of this dehumidifier? Question is, what is the size of dehumidifier? Dehumidifier. We have all the dimension of room. We have two different condition of indoor and outdoor. We have this correlation. Just we need to calculate this size of dehumidifier. Can you do that? Please note down and try this exercise right now, because I need to uh, get clarity that you got properly the psychrometric things also. So please try, and then we'll do together. So give me the answer first, and then we'll do.
Guys, calculate the length, width into height.
Hmm. Sorry.
Total ratio.
Mm-hmm.
Calculate into multiply na 30 into 30 into 12.
I sorry, I didn't get you actually. Can you repeat please? Actually, your voice is not audible.
Multiply with the length, width, and height. Total value.
Total length. Yes. So this
The
particular room
D.
length is 50,
Okay.
width is 30 feet, and height is 12 feet.
Device is breaking.
So,
Okay.
what is the ACH?
So okay, SEH.
We need this value, na?
Okay, so let's consider. Just a second. We are designing for an. Uh, mm, okay, we are designing for laboratories, and ACH. Let's consider 8.
Okay.
Okay, we'll write down here. SEH is 8. SEH. Okay. Now please try to calculate and.
So we need to access the psychometric chart also, na? Because from W1 and W2 we need that.
Yeah, yes. You need to access psychometric chart. So you can use data and X-ray calculator also, which is your things like suitable for you. You can choose that.
And please bring that Excel, na? Again.
Yes, sure. One second.
Sir, hello.
Yes, please.
It will be 179,280 BTU per hour. 280
179,280
BTU per hour.
BTU per hour, huh?
Yes.
Per hour.
Can I explain, sir? How can how I come to this?
Yeah, we'll do that. I'll get one more like 2 3 results, and then we'll discuss.
Okay,
You
okay, okay, fine.
discuss. Any other answer, please? Or you need some more time?
Sir, should we start? It's almost 9:50.
Yeah, sure. I think I'm not getting any answer. So, yeah, please, can you discuss how you got this number 179280? Please discuss how you exactly got so that.
Hello?
Yes, yes, please.
Yeah, first of all, I find out the volume.
Okay,
This is 50 into 30
okay,
into 12.
okay,
That is 18,000 square cubic feet, right?
okay, okay.
Now, I have found this yeah, uh, putting this in the equation.
Mm-hmm.
There is volume into air changes. 8
Okay.
air changes per hour
Mm-hmm.
divided by 60.
Okay. So how much it will
Yeah,
be?
2400.
So it's 2400. Yeah.
Yeah. Now, I have found the W1 and W2 for the two conditions,
Okay. Which
and that
method you have
is for
considered?
from the calculator.
Okay. Which calculator you have used?
Actually, I have a psychometric calculator itself.
Oh, you have your own. Okay. Fine. Fine.
Yeah, yeah, yeah. For sir, 22 degrees centigrade and
Mm-hmm.
50% RH,
Mm-hmm.
the humidity ratio is coming at 57.8 uh, gain per pound.
Okay. 57.8.
Gain per pound.
Okay.
And for the other, it is 76, 74.54 gain per pound.
Okay.
That is for this 48% RH and 30 degrees centigrade.
Mm-hmm.
Now, now the putting that equation 4.5 into this minus this into your 2400.
Exactly. So you got this. How exactly you can figure it out? Humidifier. So similarly, you can do for like this calculation is for humidifier sizing. Similarly, you can go for dehumidifier sizing also. So yeah, let me complete this also. So just now what you said, this is exactly correct. So just what we have to do is based on our given dimension, which is length, width, height. So we need to calculate first volume. So volume we need to calculate. So volume is nothing but length into width will be like your area. Area times of height will be volume, and then we need to calculate the total heat gain. So total heat gain, this is complete volume times of ACH. Since we are designing for a laboratory, so like 8 we have considered, and then just divide by 60, so we got Q. Now we have these two conditions. So at T in and R in, temperature and relative humidity percentage will be 22 degrees Celsius and 50% relative humidity. So let's consider these things. Since it is degree Fahrenheit, so we have to convert into this into degree Fahrenheit. So 22 will be 71.6. 71.6, and 30 will be 86. Okay, so 86. Now what we need to do, just use this calculator. So it is already uh, degree Fahrenheit. Let me check that. So we need to calculate RH. We have two options. One is RH and so elevation in HG itself, and dBT we need to calculate, which is 71.6. So just let psychometric. We got this humidity ratio is 0.00826 lb per ratio. So at this condition, let's put here. So at this condition, my humidity ratio value is, so it's WP, and
Actually, sir, I have taken the next one, 57.8.
uh, no, it
The
should
next one,
be
say,
okay. 57 per no. Actually, no, it's not. Humidity ratio we need to consider.
but this is also humidity ratio, sir. No?
No, if you open, let me open the psychometric chart. So humidity ratio kg per kg of dry air will be very small actually 0.00. It will be not mm,
Dry air.
yes, kg per kg of dry air actually. So first of all we need to consider this. Second. But your method is right actually, so maybe for that value is bit changed. Okay, let me open the psychometric chart and we'll clarify this. Just a second. Okay, so if you see this, this complete thing is your humidity ratio. So let's consider our condition itself. What is our condition at 71.6 degree Fahrenheit and 50% relative humidity? So 71.6 degree Fahrenheit is somewhere here, and 50% relative humidity will be this line. So if you see, move towards your right side, it is somewhere here. So humidity ratio will be 0.08. That whatever we got, that is actually 0.00. You can see 826. So that will be accurate humidity ratio actually. Similarly, we need to calculate for,
Sir,
yes please.
can you open the psychometric chart again?
Yeah, sure. Yes.
Uh,
I think you were talking about this, right? 56
yes,
point
yes, sir.
something.
Yes, yes, yes.
Yeah. Yeah, but actually this is uh, okay, just a second. Okay, yeah, same thing. Like it's just a, unit conversion things. So just it's like so here there is humidity actually in humidity ratio. There is no unit actually. So it's like kg per kg of dry air. So it will like humidity ratio don't have any unit, but just like here it's they've done some unit conversion also. We can use that also. So 56, if you do 0.008, let me show you into 7,000 once again, just for an example. This times of is nothing but you just now what you got 57.82. Is it this much? 57.82.
Yes, sir. Yes, yes, sir.
Yes, yes. So it's like same. Okay. So similarly for this case also we need to see from ash ratings. So which is uh, that 86 degree Fahrenheit and 86 degree Fahrenheit and relative humidity. So just need to calculate. So then humidity ratio will be 0. This one. Uh, okay, out and for your reference, also let me calculate from here equals to this times of 7,000 but 74.48. 7.74.5. Okay, so what we can do is now just need to size our dehumidifier. So dehumidifier, how much load is required, that we'll calculate now, equals to Q is our Q value is 2400 BTU per hour times of humidity ratio. Difference between humidity ratio is out minus in 25.7, and for your case it's like equals to Q is 1000. Okay, Q is Q. Okay, times of no, it's 6 minus F5 1.5. So, yeah, 17. Yeah. So your answer is same. So, but actually we need to prefer this humidity ratio 25.74. If you again, I can come to your point. That will be like this times of 7,000. You can see this result came here.
Okay, sir.
So that is how we can, size our humidifier or dehumidifier. So, like since we talk about kgs, so in terms of like what you got, that will be in terms of pounds. So lb actually BTU per hour lb. If you talk about SI unit, so BTU per hour. That's all. This much of humidifier is required for this. So you are also correct. This process also correct. We can do like any one method we can use.
Okay, sir. Thank you.
So okay then, let me since it is clearly understandable, and any doubt as of now.
No, sir.
Okay then. Okay, so let me summarize this topic. So today we start through this particularly like winter uh, load calculation. So if you have winter season and outside temperature is bit colder compared to the indoor temperature, and you need indoor bit hot, so in that case what you can do is like you can select a heating coil for that. So how much heating coil it has to be, so based on that how we can calculate these things. So we have different, like we can take this room size, and then what will be the occupancy, what are the equipments. So based on that we need to calculate the total amount of heat loss, how much it is losing through wall, through window, and through roof, through ceiling, through roof and through floor. So that we need to calculate what about the infiltration, what will be the people head gain. So that load we need to like net heat load we need to count from that, and just you need to convert into BTU hour to kilowatt. So that we will get the proper heating coil size. Okay, and then we came towards dehumidification. So as we talked about what is dehumidification, when we can use, what are the disadvantages, advantages, and how we can size those dehumidification. So just now see, we already saw a exercise where we have a particular room size, so we need to calculate our volume. Then we have two different conditions, which is at indoor and outdoor. So at indoor, based on that temperature and relative humidity, we have certain that particular humidity ratio. We can get from psychrometric chart, we can get from different like tools where you can get the psychometric properties. So using this correlation, we can easily figure it out what should be our humidifier size. Okay, so as of for today, it's like uh, enough, and next meet we'll try to do this towards the tools actually. So and also I'll talk to our team to provide this particular uh, PPT to you. Okay,
Yes, sir.
so
Or there are several PPTs. We need access of that. Please.
mhm. Yeah, okay, definitely I'll speak with them and make sure I'll you'll get access.
Okay,
Okay,
sir.
then shall
Thank
we?
you.
Yeah,
Thank
yeah.
you.
Shall we call this a meet?
Yeah, yeah, yeah.
Yeah. Thank you, everyone.
Thank
Good
you,
night.
sir. Thank you, everyone. Good night.